Hi guys, welcome back to my channel. Today I want to talk about how Faraday's law is applied to electrochemistry. All right, so as you can see here, I have a really simple setup of an electrolytic cell, right? And on my cathode side, I have this iron that's reduced to the solid iron. And then this is a really non-spontaneous redox reaction as iron with a lower reduction potential is getting reduced, but this chlorine with a higher reduction potential is getting oxidized instead of getting reduced. So this makes this reaction really non-spontaneous, right? And then because of being non-spontaneous, we want to introduce the battery that will provide the electrical energy for the flow of for the non-spontaneous flow of the electrons, right? Going from this side to this side. Okay, so, and then we know that the current equation is a current equals a quantification of the charge over time, or we can say that the charge equals current times the time, right? And then the background knowledge you want to know before we dive into the Faraday's law is that 1 mole of electron, because electrons, they have charges, right? They have all these negative charges. So 1 mole of electrons will have a 96,500 coulombs, okay? That's how much charge that 1 mole of electron has, okay? Okay, now let's dive into Faraday's law. Faraday's law says that the amount of the product in the half cell, so I can say this solid iron is the product in a half cell, right? And then how many mole of a product do I produce, or how many grams of a product do I produce? That is proportional to what? To the charge applied to the cell, okay? And then basically the charge applied to the cell is basically saying that the charge of the electrons, right? Because it's the electrons that are flowing in this apparatus, okay? So we really basically just need to know how many moles of electrons are flowing in this setup. Then we will figure out the amount of the product, right? The moles of the product, because there's really this stoichiochemistry relationship of 3 moles of electron that produces 1 mole of my product, okay? All right, so let's do a real example, okay? Let's use some numbers and dive into a real example. So on MCAT, usually the question will give you 2 things, okay? So the first thing the question stem will provide you is how much current, okay? So let's say, for example, I have a 50 amp, okay? That's how much current, okay? And then the second thing the question will tell you is usually how long has this current been applied to the setup, okay? So let's say 1 hour, okay? So this thing has been going on for an hour. So 50 amps, since we know that Q equals I times T, so T is really second, right? So 50 amp times 36 seconds, that's how many seconds you have in an hour, right? That gives me 180,000 coulomb, okay? So that's the total charges that have been applied to the cell, okay? And then we know that 1 mole if 1 mole of electron is a 96,500 coulomb, right? But I applied 180,000 coulomb. So I can really figure out 180,000 divided by 96,500 coulomb. That gives me about 1.87 moles of electron, okay? So let's just say 2 moles to make life easier, okay? Let's say it's just 2 moles of electron that we applied, okay? Okay, so 2 moles of electron that are applied to the cell, right? Because we got that from the charge, right? From how many charges are applied to the cell, that we know how many moles of the electrons are applied to this. And then, according to this stoichiochemistry relation, that 3 moles of electron will give me what? Give me 1 mole of my product, okay? But the reality is I have how many moles? 2 moles, right? After I simplified. Well, that will give me how many moles of the solid product? It's basically 2/3, right? That's how many moles of solid iron that I produced, okay? So If the question stops here, hey, how many moles of a product are produced, then that is your answer. But if it gets harder, if it asks how many grams of this product is produced, it's actually not way harder, right? You just go to your periodic table, you find the molar mass of iron, and then you do the math, you get how many grams, okay? I hope that's helpful.